Hello, everyone, and welcome back to another Planetarium show. My name is Jessica. I am the director of the Planetarium, and I completely lost my train of thought because Nova looked very cute at me. For everyone, this is my cat Nova who is joining us today. She's got cat hair. If something goes funky on my screen, it's because she sat on my keyboard. So just that's here. Anyway, hi, Jessica, director of the planetarium. Also with me tonight is one of our students who I'll let introduce herself and say hi.
Hi everyone, my name is Allie. I'm a planetarium staff member and a biochemistry major at UMD.
So, since it is the first Wednesday of the month, you did. Hold on. Okay. I don't know. Okay. Can people hear me now? I guarantee you that it was Nova. Yeah.
Jessica, the audio is working on my end. I'm able to hear it from the live stream.
Okay. Looks like it got fixed. Okay, cool. Sorry about that, folks. I told you that there might be some technical stuff because Nova likes to flop on my keyboard, but that is fixed. So I will go back into what I was saying. Our show tonight is going to be looking at the astronomical events taking place in July, and if you have any questions while we're going through, you can leave them in the comments. Thank you everyone for letting me know about the sound. But we are good to go now. So what I was talking about was on July 4th, so just 2 years ago, or not 2 years, 2 days ago, I'm flustered now. Um, we were at our closest approach, or not closest, furthest approach from the sun because our orbit is slightly elliptical. It's not a perfect circle. That means we are closer to the sun sometimes and further from the sun sometimes. So on July 4th, we were at our furthest approach from the sun. And what might a lot of people kind of are confused by this because there's a common misconception that the seasons that we have here on Earth must be caused by our distance to the sun, right? We're closer to the sun, so we get warmer, so we get summer, and we're further from the sun, we get less heat, so it's winter. And that kind of makes sense, at least for how we experience like heat sources here on Earth, or at least here in our everyday experience. But that's actually not the cause of the seasons. As you can see here, we experience summer when we're actually at our furthest point from the sun, and that's because the dominant influence that is causing the seasons on the Earth is actually the tilt of the Earth's axis. We are tilted by about 23.5 degrees. So that means in some points of the year, the northern hemisphere is tilted towards the sun, And at some points in the year, the northern hemisphere is tilted away. And of course, the southern hemisphere would be opposite. When we're tilted towards, they're tilted away. And this being tilted towards or away from the sun actually has an effect on how much sunlight we get and how intense that sunlight is. So when we're tilted towards, we're getting a lot of very direct sunlight. It's a very intense sunlight, so not spread out or weakened. And the sun is also up for a longer period. You know, our summer days are a lot longer than our winter days. And that all leads to the warming of the earth. And then in the winter, it's the opposite. Because we're tilted away, that sunlight is more spread out, so it's less intense. The sun is up for shorter periods of time, so we don't have as much warming. So it is, in fact, not our distance to the sun that causes seasons. It is this tilt. And the equinoxes, there are 2 times in the year where we're, with respect to the sun, don't seem to be tilted. And that creates our equinoxes, where we have equal day and night. All right. Moving on past that segment, let's talk about.
Jessica, we have one question.
Okay.
Do you have a mnemonic device for remembering aphelion versus perihelion?
Aphelion and perihelion.
Yes.
I do not. Yeah, I don't. I just have to remind myself anytime I have to say the words. I look it up real quick to make sure that I have it right. I will say I don't use that terminology a lot. So usually I just mention we're closer and further, and I don't give the specific names for those points. But, all right. So let's take a look at what the moon is doing. So we ended last month with a new moon. So our first phase that we're seeing of the moon in July is going to be first quarter, which is happening today. And then about a week later, on the 13th, we will see the full moon, which for July is called the buck moon. And it is going to be a supermoon, which I'll talk more about that in a second. Then on the 20th, we have our third quarter, and then we'll end the month on the 28th with the new moon. So here are those dates, the times that the moon will be up, because it is up at different points in the day and night, depending on what phase it's in, which is, of course, telling us where it is in its orbit. Now back to that supermoon. We had a supermoon last month. We're going to have another one again this month. And supermoons happen because the moon's orbit isn't a perfect circle. So just like with the Earth, where we're sometimes a little bit closer to the sun and a little bit further, the moon does the same thing, where it's a little bit closer to the Earth sometimes and a little bit further. So when full moon happens, when the moon is at its closest to the Earth, that's when it looks a little bit bigger, and that's what we call a supermoon. Now, it's important to note that it's not going to be a super dramatic difference. So you can see here kind of the comparison of the supermoon versus the kind of average size of the moon. So if you don't know that it is happening, you probably wouldn't notice, but it is kind of a cool thing to know. And the July supermoon is actually the biggest supermoon that we will have this year. Also cool to note that we have an opposite effect when we have a full moon that happens when it's furthest from the Earth. We call that a micromoon, and it's a little bit smaller than average. All right, now what about the planets? Last month we had a planet bonanza at the end of the month, and we are actually starting out July still with that parade of planets. If you get up just before sunrise, you can still catch all of the planets lined up in the early morning sky, including Uranus and Neptune, which you can't see with your naked eye, but you can see with a telescope. But the Mercury here is slowly moving closer and closer to the sun. So we really only have maybe a few more days left that we'll be able to see Mercury in the morning sky. And as Mercury gets closer and closer to the sun, it will end up kind of passing the sun, at least from our point of view, on July 16th. This is what we call a conjunction. And so for this one, it's a superior conjunction. So it's kind of passing around on the opposite side of the sun before coming back out at the end of the month. So in, about a week or so, we'll still have lots of planets up in the early morning sky. We just won't have Mercury anymore. And Venus is really only going to be seen in the morning sky. The rest of the planets, though, as we progress through the month, they're going to be rising earlier and earlier in the middle of the night. Right now, you can catch them usually after midnight, but the later we get into the month, the earlier they're going to rise. So if you're more of a late night person instead of an early morning person, by the kind of mid-month to the end of the month, we're going to be seeing lots of these planets up late at night. So this is on the 17th at about 2 a.m. We have all of the planets except for Venus up and visible. Again, Uranus and Neptune are there as well. You can't see them with your naked eye, but if you look at them through a telescope, you will be able to see, they kind of look something like this. You'll notice that they are definitely circles and not like points of light. And with Uranus, and even Neptune, depending on exactly how big your telescope is and how good your dark skies are, you may even be able to pick up on the kind of blue color of the two planets. And then on, let's see, July 20th, here we go. I have to check my notes real quick. Jupiter here is going to begin its retrograde loop, which means so from now until then and for the while, Jupiter has slowly been moving eastward against the background stars. What's going to happen on the 20th is Jupiter is actually going to stop that eastward motion and start going backwards, westward for a little while until late November before it turns back around and starts going eastward again. And so this is kind of that path that it took this year. And so you can see going here, and then in July, it's going to, right at the end of July, going to turn and start going backwards until end of November, where it starts going back again. Now, what is happening here? Is Jupiter really just doing little turns and circles in our sky? Not really. What we're seeing here is the effect of the Earth catching up and passing Jupiter in our orbits. Earth, since it's closer to the sun, moves a little bit faster in its orbit. So every so often we catch up to and pass those outer planets. This is showing an example with Mars, but with Jupiter it works the same way. So as we're catching up and passing the planet, from our point of view here on Earth, it actually looks like the planet goes backwards for a little bit before continuing on its normal motion. If you've ever paid attention, if you're like passing a car on the road, the car does the same thing when you're passing it. The car looks like it's going backwards, but until you've passed it, and then everything looks like it's going forwards again. The cool thing about this is because we are catching up to and passing Jupiter, while it's in this retrograde, that means we are at our closest approach to Jupiter for the year. And so it's going to be the best time to try and see it within this time frame. And so it'll be some really good views of Jupiter for now. And then by the end of the month, Mercury will have passed around the sun and will be just starting to peak up over the western horizon just after sunset. And so it will be gone for the middle of the month, and then right at the end of the month, it'll be back up, but this time in the evening sky. And we'll end up joining the rest of the planets in the evening sky next month. That was a lot. We have a lot going on with the planets this month. All right. Moving on from the planets, we do have a meteor shower happening this month. This month's meteor shower is the Southern Delta Aquarius, which is this one right here. It's named such because the meteors appear as if they're coming from the region of the sky associated with the Aquarius constellation. You will do notice that there are a few others that are kind of up. These are very minor showers. We're talking like a couple of meteors per hour, nothing major. The Delta Aquarids, while not a major meteor shower, it is still kind of a moderate one. So the meteor shower itself runs from July 21st to August 23rd. Peak is going to happen the night of July 29th into the early morning of July 30th. You will be able to see meteors all night long, but the best time is going to be around 3 a.m. on the 30th, because that's just when it's going to be highest in the sky, so the best time to see it. And we are in luck. The moon will have set pretty early, so we're not going to have a moon to compete with, so you'll be able to see even those faint meteor trails. And again, this is a moderate shower, so at peak, we're expecting 15 to 20 meteors per hour. So yeah, that is our meteor shower. Now next up, we're going to take a look at what the International Space Station is doing. If you didn't know, you can actually see the space station from here on Earth as it passes over the Earth in some locations. You can actually see the sunlight reflecting off of the solar panels, and that makes this bright point of light that moves quickly across the sky. Now, not all of these that you see are the International Space Station. If you go out, you can see a handful of uh, satellites flying overhead at any given time. Um, but if you want to know for sure when the ISS is going to pass over, there is a fantastic website called heavens-above.com where you can put your location and click ISS, and it will tell you for your location when the ISS is going to pass over. And for Duluth, we have quite a list for this upcoming month. We have a lot of options. Even if you are a late night person or an early morning person, we're going to have a ton of different flyovers this month. So if you're interested in trying to see it for yourself, you're going to want to find a date and time that are best for you. Nova, do not lay on my keyboard, please. And then you're going to want to look at this brightness column. So brightness is given in magnitudes, which is kind of a backward system. The smaller the number, the brighter it is. And all of these are really bright passovers, so you really shouldn't have a problem picking one of these. Now, once you've found a date and time that works for you, if you click the date, it will take you to a page that shows you two things. It'll show you a map of the sky and show you the path and the times that the ISS will be at that portion of the sky. And it also gives you some more information on kind of the exact timing of the event. So you can plan out exactly when you can go and see it, where you need to look, and know the path that it's going to take. Again, this is specifically for Duluth since that's where we're located, but you can go to that website, which is also linked in the video description, put in your location and find out for yourself, for your location, where they would be. All right, I think we have just a couple of things left. We have first James Webb update, which isn't too much past what I've already said, but we are highly anticipating the release of its first images, which is happening on July 12th. Starting at 9:30 a.m. Central Time, they're going to be releasing several different images. They're each meant to kind of showcase the different instruments that James Webb has. They've teased what a few of these images are. So one of them is going to be kind of a deep field image, which is looking back, kind of the furthest back in time that we've seen, and some of the earliest, youngest galaxies that we've ever been able to see. And then we're also getting an image of the atmosphere of an exoplanet and the composition of the atmosphere with what's called a spectrograph. I have been reading so many accounts of those lucky astronomers who are on this team and have gotten to see these images already. And they have all talked about just how stunning it is and how emotional they were. And I cannot wait to see them. So we will be sharing NASA's live stream that morning, so you can go and catch it for yourself. But if you miss it or you want to learn more about the images, you can join us next Wednesday for our live stream where we're going to be talking about those images that were released and what it all means, and probably just be giddy over this. Like, I'm hoping I will be able to say something, educational and not just be in awe. But yeah, I'm very excited. Next week. Lastly, let's talk about what the planetarium is up to. So for Friday's in-person show, all right, Nova, you on down? All right, sorry. For Friday's in-person show, we're doing Journey Through the Solar System. Our Saturday shows have changed since we are in a new month. Our family show at 2 p.m. is Two Small Pieces of Glass, The Amazing Telescope, and our evening show is Big Astronomy, People, Places, Discoveries, and I'll show you a quick trailer on those. So this is Two Small Pieces of Glass. All right. So it's about telescopes and how they helped kind of shape and change our understanding of the universe. It's a really great show. And then the evening show, as I said, is Big Astronomy.
I want to introduce you to Astronomy in Chile, a place where astronomers study the sky with the help of amazing technology and even more amazing people.
I think about it as if these photons that literally are billions of years old are arriving and I'm seeing them for the first time.
And we are taking data for projects that are breaking the limits of what we know, going beyond the limit of our knowledge. That is really fascinating, yeah.
We humans are nothing compared to what the great cosmos is.
We hope to share the wonder of the sky and the excitement of discovery with the whole world.
Okay. So again, it highlights kind of real work being done in astronomy, looking at actual observatories, mostly ones located in Chile, and the people that run the observatories and the science that's done and the discoveries that have been made. It's one that I am very excited to finally be able to show, as I have many friends and colleagues who actually worked on this production. So I'm very happy that we are able to finally show it. And lastly, we of course have our plans for the annual Dark Sky Caravan. This year's is going to run from August 8th through 13th. On Monday the 8th, we're starting off here on Facebook Live with a virtual kickoff event. We'll be joined by a couple of special guests who are going to help us kind of just learn and appreciate about the dark skies that we have here in Minnesota. And then the rest of the week, we will be at various locations hosting star parties from 8 to 11 p.m. And so here are the locations. We're starting here in Duluth and then slowly making our way up the North Shore, ending at the end of the Gunflint Trail at the Chickawauk Museum and Nature Center. Each night we'll be there from 8 to 11. If weather is ideal, we'll have telescopes out. We'll also give live kind of sky tours of what you can see. If weather isn't super cooperating, don't worry. We will still be able to give you digital tours of the sky and have some fun activities out as well. So definitely come see us at any or all of these stops and celebrate Minnesota's dark skies. And with that, I believe I've reached the end. So, did we get any other questions in? Doesn't look like it. My Facebook on my computer is not cooperating with me. All right, well, why don't we have kind of one last call for any questions that people have? I don't know, Allie, are you as excited as I am about the James Webb image?
I'm really excited. And then when I found out that the scientists who were a part of it got to see those images and they were like astounding to them, that like just made me like I had like real butterflies in my stomach. Like I'm so excited. I feel like it's just so monumental.
Yeah. I mean, quite literally, astronomy is about to completely change. Our understanding of the universe is about to completely change. We are going to learn so much with this, and I cannot wait. And as much as I am not a morning person, I am for sure getting up to watch the 9:30 stream and see these things as soon as they're released, because I cannot wait. And I have no idea if I'm going to be of any use the rest of the day or if I'm just going to be staring at images.
I think everyone in my social circle is going to be so upset with me talking about these images for like the next maybe like 2 or 3 weeks. And I'm not going to want to talk about anything else. And I'm just very prepared to be like very invested in it and definitely going to have some tissues on hand because if the people who were like expecting these images are emotional about it,
Yeah.
then I'm going to be like 10 times more emotional about it.
I cannot wait. And that's what I'm saying, like, I'm hoping that stream on Wednesday, like, will be more than just, it's so cool.
I know. Yeah.
So we got asked about solar observing. We don't do much right now. We do have a solar telescope. In earlier iterations of the dark sky, we actually started early enough to do solar observing and then transition into nighttime observing. But we don't have the staff to put on a like 6-hour event for 5 nights in a row. Because it's a lot. It's a lot. So we haven't been doing it much, although our summer campers in a couple weeks are going to get to do some solar observing with our telescopes, which will be nice. Yeah. All right. The sun has been really cooperative. Yeah, we've gotten lots of good sunspots. You can tell that activity is ramping up. And the aurora is getting really active too. If you haven't checked out our all sky camera, that's up at Chickawauk. There's a link in the video description. Go check that out because the past several nights have had some gorgeous, gorgeous time-lapse videos. And it's just gorgeous anyway. I mean, the summer sky, the summer Milky Way is so stunning. But like, yeah, go check them out. All right, well, I think we will wrap it up there. So thank you everyone so much for joining us. Sorry for the chaotic start and my being a little frazzled through the rest of it. I should know better than to let Nova on my desk when I stream, but she was yelling at me, as Allie can attest to. So, all right. Thank you. Hope you have a wonderful rest of your evening, and we'll hopefully see you next time. So, bye, everyone.